I am Shikun, you can call me Aaron. I am a research scientist at TikTok's Privacy Innovation Lab. I gave a talk in substitution of Jian last year, PEP fusion and how it could be used for advertising system. And today I'm going to talk about designing for user privacy, integrating differential privacy into ad measurement systems in practice. All right, so let's consider a consumer journey in digital advertising. A typical user could probably surf the internet and they could see an ad on their search results, or they could open social media and see an ad, or see an advertisement on the site banner of a news website they're visiting. So these are called impression data on ad publishers. So these are also called exposure points, where users are exposed to different advertising. And on the other side, user might be picked by one of the advertisement and click on the ad to actually go to a commercial website such as Nike.com, and they could browse different products and eventually buy something. And these are called the conversion data on the advertiser side. These could not only include the typical amount spent, for example, the user actually purchased something. It could also include other actions such as user clicking on something, adding something to their shopping cart, or eventually going out to the checkout stage. Different data checkpoints all the way leading to the actual conversion or the actual buying. So these, for example, of the impression data is Alice clicked on a Nike ad at 1 p.m. On May 3rd. And a typical conversion, a typical conversion, I hope that's not me. A typical conversion data could be Alice checked out a pair of Nike sneakers worth of $60 on May 6th. And as you can see, effective ad measurement is basically for ad publishers and advertisers to know, to measure, evaluate the effectiveness of their, how the advertisers' ads worked on the publisher's platform. And effective measurement require data from both the impression and conversion data working together. So this way, by correlating the impression data with the conversion data, you could see the participating parties could know, the return of investment for the advertisers' dollars. So this is an example of the actual simplified example of the tables involved in the advertising system. As you can see, the impression table consists of the users doing something at a particular timestamp involving a particular ad, and the conversion data on the right-hand side involves the user's actual purchasing behavior. And through some algorithm in the middle, we could actually calculate the effectiveness of a particular advertising campaign. And this, there's some more intricate details here. I'm just going to gloss over them. So, for example, how could you distribute the different credits to the different ad publishers involved in this journey? Because there could be multiple exposure points. There are something called a first touch logic or a last touch logic. The last touch is basically only giving credits to the last data point prior to the buying. So basically, whoever's ad, for example, maybe there's an ad on Google that leads to the final, that's directly happening before the final purchase. So Google will be the ad publisher that's taking the full credit for that. But that's called last touch. But of course, there are different methods for different kinds of advertisers, for different business logics. There's also machine learning algorithm that could be used to distribute this kind of credits to different ad publishers. And also, advertisers would want to see their results, sometimes by a particular time interval. For example, by day. They want to see how much they spent that day and how much they got back on that day. And they could also adjust the interval sometimes by hour even. And they also, of course, wanted to know at the end of the ad campaign, which could run for a month or days, weeks, or month, at the end of the day how much their total conversion value is and how much total they spent. And as I talked about in the previous example, these are how online advertising works. It's more like a toy example. But as you can see, it involves a lot of tracking of users on different platforms and combining these data together. But as the days have changed, now we are seeing a shift towards a more privacy-preserving ad landscape. So this is characterized by three aspects. I call it control and compliance and change. So the control refers to users seeking greater authority over the collection and use of their data. So you can see there's an increasing use of ad blockers and more privacy-preserving browsers. And also users are accessing control, for example, by making privacy choices provided to them on different operating systems or browsers. And also we see stricter compliance. So governments are enacting new regulations and policies to protect user data and heighten requirements for data collection, sharing, and usage. So for example, the recently introduced Digital Services Act in the EU is an example of that. And also there is the change in the operating system and browsers that are introducing technical and policy modifications on their end to restrict data collection and usage. So Apple's app tracking transparency is one such example, and also Google is piloting in their privacy sandbox initiative. So as you can see, because of this change, this poses a so ad tech are actively searching for new methods that could enable the core functionalities of online advertising while also respecting and safeguarding consumer privacy at the same time. All right, so a lot of people, as we've seen from the previous session, there are a lot of PETs. PETs are on the rise. And so privacy by design, the privacy enhancing technologies ICO has said that privacy enhancing technologies can help demonstrate privacy by design as a, and I'm blanking out, but and there are different and there are, sorry, completely blanked out. And there are different privacy enhancing technologies that could either guarantee input or output privacy. So for example, differential privacy, I think that's like the key word from all the sessions so far, is one of the method, or one of the only method that could guarantee output privacy. And there are also other types of privacy-enhancing technologies such as MPC, multi-party computation, homomorphic encryption, and TEE, trusted execution environments that are that could guarantee input privacy. And as by employing PETs, ad tech could have a chance to demonstrate privacy by design. And also, input privacy and output privacy is both important in this case. So input privacy is to protect the source data, and the output privacy is to protect the release of the outcomes. In this case, is the ad measurement results. All right, so by putting that into practice, so this is the example that we see earlier. And the input privacy could be protected by PETs such as MPC and TEE. And the output privacy is to add differential privacy to the outcome results. But it's not as simple as just adding some calibrated noise to the outcome of how much money the advertiser got. There are a lot of more nuances in this process The first I want to point out is just protecting the output result is not enough. Sometimes the intermediate results of this system could also leak user information. So one takeaway from this is to also add DP protection to the intermediate results of the system. And also there are a lot of different practical constraints that's enforced by the advertising system. For example, you cannot just add all the noise you want because this is an advertising measurement system. At the end of the day, you still want some utility out of the system. So there's the balance of utility and privacy, how much noise to add. And because of the design or the actual how advertising system works, there's, for example, the reporting interval. So advertisers want to see reporting by a specific interval. So how could you add noise to all the intervals together? That could mean a lot of noise. So how to optimize such noise addition is also important. Also, a lot of the data that we have seen in this system involves our event level privacy. Event level means the user did something on a particular platform, but for users or per user's expectations, user level privacy is more important than event level privacy. So how could we design, when designing DP, to make sure user level privacy is guaranteed? All right, now I'm going to give the stage to my colleague to talk about more of the technical details.
Thank you, Shikun, for covering the most tough part, and my job is pretty easy, just present some results. Shikun has mentioned that we need to consider both input privacy and output privacy. Actually, in the privacy-preserving as measurement scenario, there's already a lot of PET solutions, like MPC-based solutions, like TE-based solutions. But there's a missing part is that the output privacy is never guaranteed. And here I would like to give you some examples why we care this output privacy. And here is an example. And we don't restrict ourselves for the input privacy guarantee for a particular PET solution. It could be a TE solution. It could be a secure multi-party computation solutions. And here on the left-hand side, we can see that the two parties, the ads publisher and also the advertiser, they have the motivation to singling out what happens, what's the user's behavior on the other side. For example, here we cover, considering the ads publisher side, they have a user's impression data. They know that, for example, Alice click on ads for Nike shoes and at some time like 1 p.m. May 3rd. But the ad publisher is very curious whether Alice has a conversion on the advertiser side, because with this information, they kind of have the label of this event, and they can leverage this label data to train their advertising models and some other applications. But this is should be prevented because this is a cross-site tracking of users' behaviors. But with input privacy guarantee like TE and secure multi-party computation, will that happen that the ad publisher can figure out whether Alice is a conversion or not? Yes, the answer is yes. Here is an example that the ad publisher got the information of impression data and also the final report. And no matter whether TE or MPC is adopted, there's still some intermediate results that need to be reviewed to both parties. For example, when trying to match the both parties' user data to align in a user level or event level, and this matching reveals the intersection size. And normally used PSIs or private set intersection solutions, like based on ECDH, they reveal the intersection size. And based on this intersection size, the advertiser can kind of remove their user event in their database. For example, they remove Alice impression data. And then in the next round of MPC computation, they can find out that the matching result, the intersection size decreases by 1. And this is a not very efficient solution, but it's possible that given enough observations, the publisher can figure out all the whether their user is a conversion or not. And this is a basic idea. And recently there's some study on figuring out this kind of attacking method, and there's a result published on USENIX 22, and we show that in the real datasets provided by Creative, and there's a kind of 0.4 membership leakage, and we also further improve their results to provide a more efficient solution, and it's kind of like 2.5% of user membership can be leaked given this intersection size results. And here we provide a DP-based solution. It's kind of fusing distributed differential privacy with multi-party computation. And before input the user's record, both parties share a common dummy data set. And this common dummy data set can be shared by using the same seed before computation and generate this common data set. And then we shuffle this common data set with length 2 times tau, and the first tau dummy will be appended to the ID columns. And you can see that the matching results, there's some dummy variables there. The pros is that this is a combination of secure multi-party computation and differential privacy. In this case, we don't bring any noisy results for the final measurements because we can append the zero conversion values to the dummy variables. But the downside is we bring new communication due to the dummy data. We bring communication burden and also computation burden for secure multi-party computation. And considering such a case that the reporting is kind of streaming online, and we need have a more tight DP composition to reduce the dummy size. And here is on the left-hand side corner is the tight DP composition. And we compare the results with advanced composition, and we found that based on this tight composition, we significantly reduce the dummy size introduced by our DP algorithm. We also consider the DP protection for the final MPC or TE output reports, which is the measurement reports as shown. And first, following the same logic, we evaluate the potential privacy leakage, and we found that this measurement results can reveal more information even than the membership leakage, even than the intersection size leakage. And it can achieve like nearly 10% membership leakage. And here are regular ways to add independent noise for each measurement results. However, Aaron mentioned that we need to balance between privacy and also the utility. We need to further optimize the solution. We propose a solution that aims to based on matrix mechanism, and the idea is that we need to minimize the total noise during the whole period of ICE campaign. And as shown on the right-hand side of the figure, we can find out that our solution is a kind of reduce the noise the error significantly, considering existing methods that add independent and identically distributed random noise, and also some recent results based on streaming DP. Due to time limitation, I cannot go through the details here, and here's the takeaway. The advertising ecosystem is shifting towards a more privacy-preserving solutions, and MPC and TE has been proposed for ICE measurement with only input privacy guarantee. And we found that with a lot of experiments and study, we found that output privacy also need to guarantee, and it's also almost the same important as to guarantee input privacy. And without output privacy, you can see that there's up to like 10% membership leakage, and which is not accessible. And we provide DP guarantee solutions. But simply applied, the DP is not an ideal case because it's increased communication overhead, computation overhead for your secure multi-party computation solutions, and also it's kind of destroy your output accuracy. So more sophisticated optimization and tight composition analysis need to be studied to bring better accuracy. Yeah, that's pretty much.